Thank you for click on this video. I sajal.sasmal welcome you to complete lecture series of solar photovoltaics. Please click on description for playlist of complete solar cell tutorial. Let's start. Absorption of light. When the energy of a photon is equal to or greater than the band gap of the material, the photon is absorbed by the material and excites an electron into the conduction band. Both a minority and majority carrier are generated when a photon is absorbed. The generation of charge carriers by photons is the basis of the photovoltaic production of energy. Photons incident on the surface of a semiconductor will be either reflected from the top surface, will be absorbed in the material or, failing either of the above two processes, will be transmitted through the material. For photovoltaic devices, reflection and transmission are typically considered loss mechanisms as photons which are not absorbed do not generate power. If the photon is absorbed, it has the possibility of exciting an electron from the valence band to the conduction band. A key factor in determining if a photon is absorbed or transmitted is the energy of the photon. Therefore, only if the photon has enough energy will the electron be excited into the conduction band from the valence band. Photons falling onto a semiconductor material can be divided into three groups based on their energy compared to that of the semiconductor band gap. E.g. photons with energy much greater than the band gap are strongly absorbed. However, for photovoltaic applications, the photon energy greater than the band gap is wasted as electrons quickly thermalize back down to the conduction band edges. The effect of the three classes of photons on the semiconductor is shown in the two animations below. The creation of electron hole pairs when illuminated with light EPH equals HF. Where EPH greater than e.g. the absorption of photons creates both a majority and a minority carrier. In many photovoltaic applications, the number of light-generated carriers are of orders of magnitude less than the number of majority carriers already present in the solar cell due to doping. Consequently, the number of majority carriers in an illuminated semiconductor does not alter significantly. However, the opposite is true for the number of minority carriers. The number of photo-generated minority carriers outweighs the number of minority carriers existing in the doped solar cell in the dark, because in doping the minority carrier concentration is so small, and therefore the number of minority carriers in an illuminated solar cell can be approximated by the number of light-generated carriers. Thank you for watching the video. Please like and share this video. I will be so happy if you subscribe my YouTube channel. Click on description for playlist of complete solar cell tutorial.